Which graph best shows how the kinetic energy of a simple pendulum varies with displacement from the equilibrium position? So let's think about energy transfers as a pendulum swings from side to side. Let's consider the pendulum first of all in the far left position. So in the far left position, the pendulum is at its highest point in its swing, and therefore it has the most GPE and the least kinetic energy. Energy is being transferred from one form to another, from GPE to KE. Those are the two forms of energy that we have for a simple pendulum. In this position, we have max GPE and zero kinetic energy. The pendulum has stopped moving momentarily, so its speed is zero at that point before it turns around and comes back, and therefore the kinetic energy will be zero. It then swings down to the middle, it loses all of that GPE, now it's in its lowest position, so the GPE is a minimum or zero and the kinetic energy is a maximum. It then swings to the far right and the same thing happens again. So max GPE, it's in its highest position again, max GPE, kinetic energy is zero. Okay, so we've identified that the kinetic energy is zero for max positive and max negative displacement, and the kinetic energy is a maximum for zero displacement. Or in other words, it's max in the middle, zero at the ends. So there are two graphs here that satisfy that, A and D. The answer would be D. It would be a curve. So you can either remember that it is always a curve rather than a set of straight lines, like in A, it's always a curve. But if you wanted a bit more detail, that curve there has the equation of a quadratic. And we can derive that. You don't need to know that for your exams, but I can show you if you like. So if we think of the equation half mv squared, that's the kinetic energy. We can use V is equal to plus or minus omega square root of a squared minus x squared. Some exam boards give you that equation, some don't, so you might have seen that before. Kinetic energy then becomes, replace the V with what we have here on the right hand side, square that, we get omega squared brackets a squared minus x squared. So that's your KE. This is a quadratic because we have x squared over here. If you were to set this quadratic equal to 0, you end up with x being equal to plus or minus a, which are these two positions here and here. When kinetic energy is 0, the displacement is the negative amplitude or the positive amplitude. And if you were to set x to be 0, which is the middle position, we end up with kinetic energy is a half m omega squared a squared, which is the maximum kinetic energy, a half m omega squared a squared.